Hello everyone. Today we will discuss chain of donuts problem of CodeChef September 2015 long challenge. We highly recommend you to read the problem before continuing with the video. The link of the problem is given in description. After reading the problem, you will notice that the main logic behind the problem was to sort the smaller chains as per their size and use the smallest one first to use as a connector. Let's suppose we have three smaller chains of size 1, 2 and 3. Let's name them as ABC. Now if we use A as a connector, then we can cut A and use A as connector between B and C. So number of cuts will be 1. Now let's consider that we use one of the donut from B as the connector. So first we connect B and A using that connector. So for that we need one cut, and again the AB chain has to be connected to C. So again we have to use one of the donut from AB as the connector to form chain with C. So the number of cuts will be 2 at the end. So clearly we can see that if we want to minimize the number of cuts, then we have to select the smallest one first as a connector. There are 4 cases in this problem. Let's understand each of them. Case 1. Let's suppose we have a string, we have chains like this. One chain is of size 1, second is of size 2, third is of size 2 and fourth is of size 3, but third and fourth are connected. So we need 2 more connections to connect these 2 chains. So but you can notice that if we use this one as a connector between these 2 guys, then 2 and 2 are connected, as you can see in this colored format, and 1 has been reduced to 0. So in the end we get 3 chains of size 2, 2 and 3 with one donut between them as a connector. This was first case. This is the code for the first case. That is, if we check if I is less than M1. What is M1? M1 is the total number of connections we needed. Here we needed 2 connections, right? 1 to connect between 1, 2 and 1 to connect between 2, 2. And the number of donuts available for was 1. We select the minimum first. So here the minimum is 1, so we select this. If this value is equal to M1 minus 1, M1 is the total number of chains needed, and so M1 is 2 here and the value is 1. So if this value is equal to M1 minus 1, then we have to increment counter with I. That is, we are using this donut as a connector, so we are incrementing our count with this number, plus we are breaking the loop with flag equal to 1. Flag is used just to indicate that we have to break from the outer loop also. Now let's take example case 2. In case 2, the value in the smallest chain is less than M1 but not equal to M1 minus 1. Here M1 is the total number of connectors needed. Here the total number of connectors needed is between 1 and 1, so 1, between 1 and 2, so 2, between 2 and 2, so plus 1, 3, between 2 and 3, so plus 1, 4. So total number of connectors needed is 4 and value is 1. since it is not equal to 4 minus 1 m minus 1, so this is case 2. In case 2, what we are doing is decrementing m1 to m1 minus I minus 1 and incrementing the counter with I. So we are telling by incrementing the counter, we are telling that okay, we will be using all the chains from all the donuts from this chain. Here the number of donuts are 1, so we will be using one donut to connect between, let's say, 2 and 3. There is a connection here 2 and 3 now, and since it is 0, so the total number of connectors needed will be now between 1 and 2, between 2 and 2, so total will be 2. Previously it was 4, now it is 2 because one chain is also disappeared. Now let's take example for case 3. For case 3, let's say we have these 3 chains, smaller chains, and we want to connect them. So let's say we use one of the donut from 2 as a connector between 3 and 3. Now we want to connect 1 and the chain 3 3, but we can't reduce 1 to 0, right? So what we are supposed to do is decrement 1 from the second chain, that is here it was 3 3, so we are decrementing 1. We are using one of the donut from this group and not from this group, the smallest one, and we will be using a chain. Or what we can do is, if such case occur where the value here the value was 2 and the required m1 was 2, so we skip this number, that is we don't use any donut from this chain, but we will be using donuts from the next chain. Here next chain will always be having more donuts, so here the m1 was 2, so we require 2 connectors. We will be using 2 connectors from this chain, so that we can have chain like this, chain of 2, chain of 1 and chain of 3, in which they are connected with each other by one donut. And there is fourth case. In fourth case, the value in chain is more than the number of connectors required. Here the connector required is 2, right, between 3 and 5 and between 5 and 5, and the number of donuts available in the smallest one is 3, so we can use 2 from this smallest one to connect one between this one and one between this one. These are the 4 cases. So for computing these values, we need to sort the array. In C language we have Q sort, but we can't use it because its worst case time is O of n square, and our question has some test cases in which worst case occurs, so we want to avoid Q sort, or we can use some fast input output method. But there is one more method which we would like to share, and I think the problem was telling us to use that method because note here that the value of AI, that is the sizes of smaller chains, is 1 to 10 raised to 5. So instead of sorting the array like this, so we can use a single array of size 10 raised to 5, and the indexes of this array act as the values. So suppose we have this array 1 2 1 2 3, So instead of storing the values as they are given, what we can do is, say if we scan 1, then we increment our a of say this is array A, so we are incrementing a of 1 by 1. Then we scan 2, so we increment our second number from array A with 1. Then we scan 1, so again we increment 1, a of 1, so we get 2. Then we scan 2, we increment a of 2, then we get 2. Then we scan 3, we increment a of 3, so we get 1. So we have this array. Note that we haven't yet sorted the array, and we don't need to sort it, because now if we run a loop from this point till the max number, here max is 3, so we check the count. Okay, the count is 2, so we will, inside this for loop, we will run another loop for count equal to 2, and that is we will be using 1 for 2 times, then 2 for 2 times, then 3 for 1 time. Let's understand the code first. Here I am declaring an array and initializing it to 0. Then I am scanning the sizes of smaller chains, and I am incrementing that index b of x and also finding the max among them. This is for the first subtask when n equal to m. For that we write print n by 2. m1 is the number of connectors required. It will, in the start, it will be equal to m minus 1, because for connecting 3 we require at least 2, at most 2. So after that we are running this loop. So this scanning process helped us to form this array. So after this we have this array of a of 1 equal to 2, a of 2 equal to 2, and a of 3 equal to 1. Now for every index, let's say we have 1, so we will check if b of I equal to 0. If it is 0, means we don't have any chain of size of total number of donuts in it equal to I, so we will continue. Else we are initializing flag to 0, and we are going inside a while loop which will run for the value time. The value here was 2 because there are 2 ones, right? So it will, the while loop will run for 2, then for 2 it will again run for 2, and for 3 it will run for 1, as the value is 1. So it will run for the value number of times, and inside that we have this all 4 cases, and in this while loop will also break when case 1 occurs or case 4, that is the end cases. In case 1, if you recall, we have I equal to m1 minus 1, or I is greater than m1, and if flag is set to 1, that tells us that we don't need to continue with a for loop, that is this array 1. So first we check 1, like this one, we will check all the ones. So after checking all the ones, we notice that our m1 will be equal to 0, so we will break the for loop also. In the end we are printing count, that is the number of cuts required to form the final chain.